Welcome again to Math 800 Pre-Algebra. Today we are doing section 6.3 Proportions. Our objectives: 1. To write proportions, 2. To determine whether proportions are true or false, and 3. To find the unknown number in a proportion. A proportion states that two ratios, or rates, are equivalent to one another, are equal. Here is an example of a proportion. In this case, we're comparing the rate $20 is to 4 hours to another rate $40 is to 8 hours. We would read this as $20 is to 4 hours as $40 is to 8 hours. Here is your first rate, here is your second rate. The as is indicating that they are proportionate to one another, which is the same as saying they are equal to another. Now we will write some proportions. 6 feet is to 11 feet as 18 feet is to 33 feet. Our first ratio is 6 feet is to 11 feet, so that's 6 over 11. Our second ratio is 18 is to 33 feet. Since they have the common since they have the same unit, this is a ratio and our units cancel out. And we will write our answer as 6 is to 11 as 18 is to 33. $9 is to 6 liters as $3 is to 2 liters. In this case, we have different units, so this is a rate. Our first rate is $9 is to 6 liters, or $9 over 6 liters. And our second rate is $3 is to 2 liters. $3 is to 2 liters. In this case, because it's a rate and they have different units, you must leave your units in the answer. So this is a proportion of ratios, this is a proportion of rates. Example: determine whether the proportion 5/9 5 is to 9 as 18 is to 27 is true or false by reducing each ratio to lowest terms. 5/9 is already in lowest terms. 5 is prime and 9 has no factors of 5. So we must simplify 18 over 27. We can divide both the numerator and the denominator by 9, and it simplifies to 2/3. 5/9 is clearly not the same as 2/3. Therefore, this is not actually a proportion. They are not proportional because they are not equal. Second example: determine whether the proportion 16 is to 12 as 28 is to 21 is true or false by reducing each ratio to lowest terms. Notice already that we have an improper fraction compared to an improper fraction. Little signs like that can clue you in to something not being in proportion from the beginning. If one were improper and one were proper, there's no way they're going to be equivalent. In this case, they are both improper fractions, so we should simplify both of them. 16 over 12, I can divide both numerator and denominator by 4, and I get 4/3. 28 over 21, I can divide both numerator and denominator by 7, and I also get 4/3. Since they both simplify to 4/3, they are in fact equivalent, so they are in fact proportional. So these two ratios are proportional because they are equivalent. They both simplify to the same number. Objective 3. Find the unknown number in a proportion. A quick note: there are several ways to solve proportion problems. One method involves using a process called the cross product or cross multiplying. I personally do not like the cross product and cross multiplying because so many students find it so easy, they find it too easy, and every time they see a fraction, they do the cross product, no matter what the situation is. If you're going to use the cross product or cross multiplying, please note it only works when you have two fractions set equal to each other. It does not work for adding, subtracting, multiplying, or dividing. It also doesn't work if you have more than two fractions set equal to each other. When you get into your next math class and into some of your sciences and business classes, you're going to have equations that involve more than one fraction on either side. You cannot use the cross product or cross multiplying in those situations. Since the cross product, the cross multiplication is so limited, I feel like it's kind of a waste of time to teach you a method that can only be used in a few circumstances. So instead, we are going to use something that we already know, and that's the basis of algebra, that you can do whatever you want to an equation as long as you do it to both sides. You should already know that. We've talked about this several times in this class. So we're not actually using anything new. We're simply applying something that you've already learned to a new situation. So here is the process I recommend using. First, find a common denominator by multiplying the two denominators together. Don't actually multiply them together, leave them written as a multiplication problem, such as 6 times 10 or 3 times x. Notice that this is just a common denominator. It may or may not be the lowest one. In this case, we aren't that concerned whether it's the lowest common denominator or not. We simply want a common thing that shares both the denominators. Step 2 is to multiply both sides of the proportion. Because we have an equal sign, we're going to do it to both sides, and you're going to multiply by this common denominator you found. Then you will cancel out the common factors and multiply what is left, and then solve the equation by dividing both sides by the coefficient of the variable. So we'll solve like normal. Lastly, as always, you should check your answer in the original problem. Example, find the unknown number in this proportion. 16 is to x as 32 is to 20. I should note there are other ways to do this problem. And if you do it by saying, well, 32 divided by 16, or 32 divided by 2 is 16, therefore 20 divided by 2 would be 10, that's fine as long as you show me that work. Again, if you use the cross product, that's fine as long as you show me your work. I, however, am only going to demonstrate with the method I recommend. So first step is to find a common denominator, which is just going to be my two denominators multiplied together, x times 20. And I'm going to leave it written like this, x times 20. Now I'm going to use the very basis of algebra, which says I can do whatever I want as long as I do it to both sides of this equal sign. And what I'm going to do to both sides is multiply by x times 20 over 1. So I have an x times 20 over 1 multiplied on the left and an x times 20 over 1 multiplied on the right. Notice that on the left side of this equal sign, so imagine there's kind of a fence here, on the left side of this imaginary fence the x's cancel out. On the right side of this imaginary fence, the 20's cancel out. And now I'm going to multiply what's left. 20 times 16 divided by 1. Well, notice dividing by 1 doesn't do anything, so I'm simply going to do 20 times 16 is 320, and 32 times x we simply write as 32x. Again, over 1, the 1 in the denominator doesn't do anything. Now we will solve like normal. We want to get x by itself, so we'll divide both sides by 32. 320 divided by 32 is 10. So therefore x equals 10. You should check this by going back to the original proportion and plugging it in. So 16 over 10, does that equal 32 over 20? Notice how I have a question mark because I'm not actually sure yet. Let's simplify both ratios. 16 over 10, you can divide numerator and denominator by 2. 32 over 20, I can divide both numerator and denominator by 4. And they both simplify to be 8/5. Notice our answer is not 8/5. Our answer is 10 equals x. It's simply that we wanted to check to make sure 8/5 that the two ratios simplify to the same value. So our final answer is 10 equals x. Another example. Find the unknown number in this proportion. 7 is to 12 as 15 is to x. A quick note. If the answer you have is not terminating when you do your long division, or repeating itself by the time you get to the 10,000th place, then just round your answer to the nearest thousandth. In general, on your quizzes and on your exam, I will give you problems that either terminate, which means they end by the time they get to the 10,000th place. They will have repeated by the time they get to the 10,000th place, or I will specifically tell you to round. So just keep an eye out though, in the few cases where you're not specifically told to round and you get to the 10,000th place and it hasn't terminated or started to repeat, then just go ahead and round it to the nearest thousandth. So our proportion is 7 is to 12 as 15 is to x. Our common denominator would be 12 times x, or x times 12. It doesn't matter what order you have them written in. We're going to multiply both sides of this proportion by x times 12 over 1. Again, I can do this because I'm doing the same thing to both the left and right side of this equal sign. Remember that imaginary fence? I'm doing the same thing, and I can do whatever I want as long as I do it to both sides. Now the common factors will cancel. The 12's cancel on the left side of the fence. The x's cancel on the right side of the fence. We multiply what's left. X times 7 we simply write as 7x, and 15 times 12 is 180. Now we'll divide both sides by 7 to get x by itself. And here's where we have to be careful. One option is to leave this as the improper fraction 180 over 7. It cannot be simplified. We're simply done at this point. The other option is to go ahead and do the long division, but you'll notice if you do the long division, it does not terminate and it doesn't repeat by the time you get to the 10,000th place. So in that case, I would round. Notice how I no longer am using the equal sign. Equal sign means the thing on the left and the thing on the right are identical to each other. They are equal. And x does not actually equal this. It is close to, but I had to round, so I can no longer say it is the same as or equal to. I have to use the squiggly equal sign, which means it's close to, but not quite. Another example. Find the unknown number in the proportion 2 1/5 is to 6 as x is to 10. So we're going to follow the same process. The common denominator I'm going to use is simply going to be 6 times 10. Now, I should note, you could go ahead and use 60, or you could use the least common denominator of 30. All three of them will work. I am choosing to leave it written as 6 times 10 and leave it written as a multiplication out of pure laziness, and we'll see why in a second. So I'm going to multiply both sides of this proportion by 6 times 10 over 1. So here's my equal sign. I'm doing the same thing to the left as to the right. And you'll notice that by leaving it in its multiplied form, I can just very quickly cancel the 6's and cancel the 10's without having to do any additional work. That's why I left it that way, purely out of laziness. Again, you could have used 60, it would have also simplified, or you could have used 30, that also would have simplified. Now I have to multiply what's left. I know some of you are still struggling with fractions, so I will take a moment to explain 10 times 2 1/5. So 10 times 2 1/5, write 10 as 10 over 1, write 2 1/5 as the improper fraction 11/5. You could multiply this together and have 110 over 5 and then simplify, or again, out of laziness, just rewrite 10 as 2 times 5. The 5's cancel, and then 2 times 11 is 22. So we should get 22 equals 6x. Now we will divide. We'll have to solve this, so divide both sides by 6. And again here we have a moment to make a decision. You have two choices, potential choices. One is to do the long division and get a potential decimal, and the other is to leave it as a fraction, either an improper fraction or a mixed number. Use the original problem as a guide. If the original problem had a fraction or a mixed number in it, then leave your answer as either a fraction or a mixed number. So in this case, I'm simply going to simplify 22 over 6, divide both top and bottom by 2, and get 11 over 3 equals x. You could also write it as the mixed number 3 2/3 equals x. I would accept either of these answers. I would not accept the decimal because you were not given a decimal to begin with, particularly in this case because your answer would be a repeating decimal. Last example, find the unknown number in the proportion 1.5 is to 0.6 as 2 is to x. Our common denominator will be 0.6 times x. Multiply both sides of the proportion by 0.6 times x over 1. We will cancel out the common factors. On the left side of the equal sign, the 0.6's cancel. On the right side of the equal sign, the x's cancel. X times 1.5 we'd simply write as 1.5x, and 2 times 0.6 is 1.2. And now we will solve this by dividing both sides by 1.5. Again, here you have a choice. One option is to leave this as a fraction. You would first multiply both sides by 10 in order to get whole numbers, and then you would simplify by dividing by 3, and you would wind up with the fraction 4/5. Your other option is to do long division and get a decimal. Since the original problem was given to you with decimals, your answer should probably be a decimal. And in fact, that's how I have it written, x equals 0.8. That concludes section 6.3. Your next step is to complete the worksheet for section 6.3, that's worksheet 35. Then check the key for worksheet 35 in D2L. Then complete the online homework for section 6.3 through My Math Lab, and lastly start on section 6.4.